Hello, everyone, and welcome to our webcast, where we'll introduce you to Arnold and 3ds Max. We have Renu Muthoo with us from ASCENT. So, Renu, I'll pass things over to you.
Thanks, Green. Welcome, everyone, and thank you for joining us for today's webcast session. In this session today, I'll be talking to you about the newly incorporated renderer, which is called Arnold in 3ds Max software. For those of you who have not attended any of my previous webcast sessions, I'll introduce myself first. And for those of you who have already attended some of my sessions, please bear with me. My name is Renu Muthoo, and I'm an instructional designer with ASCENT. My main work here is to write and update the courseware material, including the training guides for various Autodesk software products such as AutoCAD and other AutoCAD vertical products, and they include AutoCAD electrical, AutoCAD mechanical, plan design, and so on. I also create courseware material on the Autodesk visualization software products, and that includes the Autodesk 3ds Max, Autodesk Showcase, and VRED Professional. As always, I'll be explaining the topic with the help of a PowerPoint presentation. That is what you can see on the screen. And then subsequently, I will also demonstrate it in the 3ds Max 2018 software. So, okay, let's get started. So today's topic is about the newly incorporated Arnold Renderer. I'm taking the information from our 3ds Max 2018 Fundamentals Training Guide. In this webcast, I'll be introducing you to the solid angles Max to A, which is now incorporated into 3ds Max as Arnold. I'll be presenting some parts of Chapter 6 and some parts of Chapters 9 and 10 of the training guide. So Chapter 6 is the materials chapter, and I will be teaching you how to create Arnold materials that come along with the Arnold renderer. I will be pulling information from Chapter 9, which is the lighting and cameras chapter, and talking about the Arnold Lights provided by the software. And finally, I'll be taking the information from Chapter 10 of the training guide and give you an overview of the options that are provided to set up the Arnold renderer. Just to add, this newly incorporated renderer replaces the NVIDIA Mental Ray renderer, although 3ds Max is still compatible with the Mental Ray renderer, but it does not come in as a built-in renderer any longer. So Arnold Renderer. The Arnold renderer is a physically accurate renderer that renders by tracing the light paths and by progressively refining the image until it has completed the rendering process. This means that it is a ray tracing renderer and brings in realism and creates high-quality photorealistic images. It is a CPU-based render and does not take into consideration the graphics or video card of the computer. Setup is minimal and simple, similar to a point-and-shoot camera. It supports both physical materials and advanced Arnold materials. Just one feature in the physical materials, there is one feature that's called the custom reflection curve feature, and that is not supported by Arnold. Rest, everything or the physical materials is supported by Arnold. In addition to the above materials, that is the physical materials and the Arnold materials, there are certain other materials also that are supported by Arnold, and they include multi-sub-object, double-sided, DirectX, and shell. It supports photometric lights and sun positioner daylight system. In addition to the photometric lights, it also has the Arnold lights, and these have been provided and with the software. And as the name specifies, they work specifically with the Arnold renderer. Now, as we all know that to create believable visualizations, materials play a very important role. So along with the renderer, a new shader library has been provided by 3ds Max, which is suited to work explicitly with the Arnold renderer. Once you set Arnold as the current renderer, the Arnold specific components become available for use. This means that once you have set Arnold as the current renderer, the Arnold material library, it becomes listed in the material map browser of the material editor. So as mentioned earlier, you can also use the physical materials provided with the software, and they work as good as the Arnold material. But it is just personal preference. Maybe you feel more comfortable using the Arnold materials because they are really easy. It has an easy interface, and it also follows a logical layout. So at that time, you can switch on to Arnold materials and use them for the renderer. So like physical material, Arnold materials are also physically based, and which means that they are real-world materials. Now, Arnold is grouped into 4 categories you can see here on the screen, and these are AOV, built-in, surface, and utility. So the AOV, it is a little bit advanced material library there, but I'll just touch upon it and just give you a little bit of information about those AOVs. So they are arbitrary output variables, and these enable you to render a scene using different shading components and features. So you need to set those AOV through the render setup dialog box first. So these are used when rendering a scene for compositing. Now, those of you who are familiar with compositing, you will know that it's very useful to separate out various elements of the rendered image. For example, you want to have a separate diffuse path and a separate reflections path. This way you can make changes to individual passes only. These images are called AOVs. You can combine those at a later time. As I mentioned earlier, a new AOV file needs to be created before you write an AOV. And it is done in the render setup dialog box, and there is the AOV tab there. Now the built-in category, it contains different surface shaders. Most commonly used shader with Arnold is the standard surface shader, and that is inside the built-in category right here, the standard surface shader. The surface I'll be talking to you about the standard surface shader after this slide is completed, because that's where we will be making a little bit of changes, and I'll show you how to create different kinds of materials using this standard surface shader as the base. Now, there is also a surface category. Now here, if you see among the 4 top categories, the surface category, it contains 2 additional surface shaders. One is skin, and the other is two-sided. So for skin, as the name specifies, it can be used for character models and to show skin. And two-sided material can be used to apply 2 different shaders on either side of a two-sided surface. Now, the utility category contains the maps to material and the pass-through options. So it has 2 more materials there. And the maps to material option enables you to use the maps directly on the objects in the scene. Now, the next slide, we'll be talking about the Arnold material, specifically Arnold material, the standard surface material. So the standard surface shader is in the built-in category, as I mentioned earlier, and is also the most commonly used shader with Arnold. It is a physically based shader and enables you to create different types of materials by modifying its parameters. So I have the parameters for the surface shader open right here. The picture is right there. So it contains a diffuse layer of color. So the base color here, it's basically the diffuse layer of color. And then using other group of parameters, you can create metals, you can create plastics, stone, glass, and et cetera, et cetera. So it has a specular reflections rollout, and this layer, which here you can modify to create metals. So in the specular reflections rollout, this is the metalness, and the range is from 0 to 1. So any number in between, if you increase the metalness, the value of metalness, the more metallic looking the material will be. Similarly, there is roughness here, and again, it ranges from 0 to 1. The value ranges from 0 to 1, and the 0.1 or the 0 value of roughness will give you a very, very sharp image of sharp clear coat on top. So what it does is the specular reflections are very small and very, very sharp. So it gives a shiny, shiny surface. So if you want something like a rough material to make, you want, for example, concrete to show or something else which does not have those specular reflections, then you need to increase the roughness here. Then we also have, it contains, also has this transparency rollout right here, and these can be used to create glass and other transparent looking objects, materials like water, etc. So then you can also, there is another rollout, which is the subsurface scattering parameters that creates organic materials, and such as skin, and that do not reflect light at the surface, but scatter or absorb light below the surface. So that was about the Arnold Materials. And now I will demonstrate about the materials in the software, in the 3ds Max 2018 software. So as you can see on my screen, I have already rendered a candle holder, and it has been placed in, there are 2 walls and then a countertop. And I have already applied the surface, standard surface material to the 2 walls. There's a green colored standard surface material, a cyan colored standard surface material, and a pink or a magenta colored base standard surface material. And then I have also applied a royal blue kind of color to the candle holder. So what I'm going to do, this is a rendering of that, the scene. And what I'm going to do is now I'm going to open the Slate Material editor and tweak the parameters of the materials that has been applied to the candle holder and show you how to create metal and how to create glass. And it is very simple and straightforward to use. So let me open the Slate Material editor. Yeah, it just takes a little bit of a lag. Okay, so we got it here. So the Slate Material editor right here. So you can see, as I told you before, the candle holder, I have a standard surface material on the candle holder, countertop, left wall, and right wall. So I'll be tweaking the parameters of the candle holder material, and that is right here. By double-clicking, I'll open its parameter editor, and it's right here for the candle holder. So to create a metallic-looking object, I'll be creating a brushed gold kind of a metal-looking material for the candle holder, and that can be done first by changing the base color to a golden kind of a color. So when I click on the swatch, as regular, you use the color selector. So I'll be applying a gold color. So, and 5, and say enter. So here, this color looks okay, for the time being, and it is a gold color. Now to make it metal looking in the specular reflections rollout in the metalness, so as I said, ranges from 0 to 1, and I will give a 0.8, which is quite high value to its metalness. And then I will want to make it into a brushed metal. Now, right now, because it has a roughness of 0.1, the candle holder, you can see those specular reflections. They're very small and very, very shiny. It makes the material look very shiny. So if we want to give it a brushed metal look, then I will increase it to 0.4 and then press enter. So that has been taken. I will start rendering it. So it will take a couple of minutes because there is a little bit of a lag when the WebEx is being used, but it happened pretty quickly. So you can see it's still rendering. It's a bucket renderer. Arnold is a bucket renderer, and it's rendering, and you can see a metal-looking candle holder, which has a brushed gold metal-looking material on it. So this was so easy to create just by tweaking two of the parameters in the specular reflection. You were able to get a metal-looking material. So similarly, if I want to convert it into a glass-looking material, a transparent glass-looking material to the candle holder, we will just change a few parameters here and there, and you will see in no time we'll be able to create a glass-looking material. So in the color layout, so for glass, as you know, we need to have a black material to begin with. So it's 0, 0, 0 to create a black material base color. And then because it is not a metal looking material, so we will move this to 0.0 back, or you can keep it at 0.1 also. It doesn't really, it's not that important. And the roughness will move it back to 0.1 and make it quite shiny. Now, in the transparency rollout, this is where the metal, if the material is going to be opaque or if it's going to be a see-through, a frosted glass look, or a glass look. So you can get that by just changing those values in the general area of the transparency rollout. And it ranges from 0 to 1. So the 1 will be the complete transparent material, whereas 0.45 can be more like a frosted glass look. So I'll make it 1.0 and then enter, and now I'll render the scene again, and you will see that it will be a glass looking, a glass material will be applied, and it will be a see-through material for the candle holder. So there it's still rendering. It takes a couple of minutes to render, and once it's done, you will see that a glass looking shiny glass material candle holder is present. And the thing is that so you can see how easy it was to create from a plastic looking material to a metal looking material to a glass looking material. All was done in just no time, and by tweaking just a value here, a value there. So it's pretty easy to use, and pretty much not like you don't have to extensively go into different change different values and change different attributes to make it look metal looking or glass looking, and so on and so forth. So now let's go to the next slide. So the materials part is done. That was the Arnold Materials, and now we'll be talking about the Arnold Lights. So again, although the photometric lights, they work very well with Arnold Renderer, the 3ds Max software provides you with the Arnold Lights as well. And these are specifically meant to be used with this renderer. It has parameters that are geared towards rendering using Arnold. So it has, in the general properties rollout right here, you can see this is the parameters of the Arnold light. And in the general properties rollout, you can toggle the light on and off. And you can also set the light as either free or targeted. So by default, this targeted is cleared, and which automatically creates the light as a free light. You can select the shape of the light, and the shape selected controls how the light is emitted. So by default, the quad option is selected, which illuminates a rectangular area and emits the light only in one direction. Then there is this color and intensity rollout. You can set the color of the light source here. So to make the light add a warmth to the scene, you can use the Kelvin option, which represents the color of the light. So you can add warmth or you can add a cool tone. So by changing this Kelvin value here in the color intensity rollout. So typically you're required to adjust the intensity and the exposure. These two parameters are really important. So you need to adjust those two to get a good render in the scene. So in the then there is also, so we'll be today, when I'll be demonstrating how to create light, we will be just tweaking these two parameters in the intensity rollout, and you will see how differently they will work from changing one intensity to another intensity. So there is also an rendering array rollout, and you can adjust the quality of the specular highlight and shadows. So increasing the samples value reduces the noise in the shadow areas, but it increases the render time. Then also you have the shadow rollout, where you can have whether you want the light to cast shadows, like for the objects to cast shadows, or you don't want the light to be such that it will cast shadows on the objects will cast shadows. So you can just switch it on and off right here. Now let's get into the software demonstration of the color intensity, the Arnold Lights. So again, I have the same similar kind of scene, which has two walls and a countertop, and then the candle holder is there. So if I render it to begin with, the camera view, if I render it, you will notice that it has the original default lights in there. So that's what is casting lights, but we have not per se added any light to it right now. So as soon as it's done, I'll just close it, and then we'll add two Arnold lights to the scene to illuminate the scene. So it takes a minute or so to complete. Done. So to create a light, Arnold light, in we need to go into the Create and Lights category, and then in the rollout, you can see in the drop-down menu, you can choose Arnold, and then this Arnold light here. So once it's highlighted, that means it's ready to create a light. So in the top view, we'll create one light just in the candle holder, and the second light, so I'm still in the Arnold light command, and clicking will create another light. So I'll create another light right here. But I don't want to click anymore. That will create another light. So I'm going to hit Escape to exit the Arnold light command mode. Now, as you can see, there are two lights. The one that is highlighted or selected right now, you can see a line coming down. What this means is that shows in which direction it is going to emit the light, because this is a directional kind of a light. As I told you before, the shape of this light is quad, and which means that it is emitting light only in one direction. So this is the direction. If I select other light, it's the same direction. It will be facing the same direction. So what we can do is right now, if I render the scene, which I don't want to render, so it will be totally black because the lights are being emitted just below the countertop. So there is nothing falling on the candle holder or on the walls. No light is there. So we'll move the lights up by select and move, and in the Z-axis, we'll move them by 500 units up. And similarly, I move the other one as well. $500 units, and both these have been moved up now. So you would assume that moving those two lights up, now they are casting the emitting light onto onto the candle holder, but that's not the case. If I render the scene, you will, I have to render the camera viewport. If I render it, you will notice that it will be kind of black. So it will take a couple of minutes, and that's because the intensity, we have not done anything with the intensity and the exposure parameters of both the lights. So, so what it is doing, although it is emitting light, but the intensity is so low that you cannot actually see anything in the scene. So once this rendering is completed, we will go and tweak those the parameters of those two lights, and then proceed from there. So we'll select the light, and in the parameters rollout, in the color intensity rollout, you have the color and then the intensity. These two need to be tweaked or changed. So we'll change this one to 10. And this exposure is, again, it is intensity as well, but it is just a multiplier of that intensity, because when I enter a value here, you will see the resulting intensity will be multiplied that many times. So hit enter, and there you go, you see that. So similarly, I'll just select the other light and change only those two things, that is the color intensity. Make this 10 and make this 16 and enter. And also there is this cast shadows, whether you want to cast the shadows or not. So for both the lights, we are casting those shadows here. So we'll leave it as is and render the scene again. So it will take a couple of minutes to render it, and once so here you go. So now you can see that both two Arnold lights are illuminating the scene, and it has a brushed metal kind of a material that we had created in the previous demonstration. And also it is casting light, casting a shadow on the wall as well as on the floor. So both the lights are casting those shadows. So once, so we will now go into and I'll just close this to make it easier, because then my WebEx runs faster if I have too many sessions of 3ds Max going on. So it becomes a little slow and there's a lag to it. So now the next one is the render setup. So as mentioned earlier, Arnold Renderer is a ray tracing renderer, and it provides advanced physically based rendering. It creates highly realistic and great quality photorealistic images. The Arnold Renderer setup contains options that are easy to set and quite easy to work with. That's the same is the case with all the things that are associated, elements that are associated with the Arnold Renderer. So you saw how easy it was to use the materials. You saw how easy it was to use the Arnold Lights, and similarly, it's very easy to use the render setup. So the main options that control the rendering image are in the sampling and ray depth. So it's the sampling and ray depth rollout right here. So here you can control the quality of the rendered image, and you can also reduce the noise in the rendering. It's basically where overall rendering quality is controlled. So in the general area, there are samples and there are ray depths. So increasing the number of samples improves the render quality, but it also increases the rendering time. So you can increase sampling for diffuse, specular, and transmission. Now there is also this camera AA, and it is a multiplier. It is the same thing. It will increase the ray depth and the samples, but it will do it for all the three of them. So it will affect whatever changes you make here, it will affect diffuse, it will affect specular and transmission as well. So increasing its value further extends the rendering time. So increasing the diffuse samples reduces noise and increases image quality. The ray depth specifies the number of times a ray is calculated in a scene. So increasing the ray depth brings in more light by reflecting more light in the scene. So diffuse ray depth increases the brightness of the materials, and the specular ray depth is meant for reflectiveness. So if you're rendering an indoor scene which has the daylight system or something like that, and the light is coming in through the windows, you need to increase the transmission ray depth to see the light and reflection outside. So generally, if you don't increase it, you will see dark everywhere outside. So there are other options, but these are the main options that are used every time. So I'll touch upon the rest of the options for the render setup as well. So just quickly, there's a filtering rollout, which contains filters for different amounts of blurring. Recommended is to use Gaussian or Blackman-Harris. Right here, we have used Gaussian. And we don't need to change any of those values or anything else here. Clamping, although clamping is clamping sample values is quite useful sometimes, because it's for what happens. It's if you have sometimes you have super bright pixels and they are reflecting and they become like very, very bright. So to blur them out to match with the others, you can give this clamp sample values. Now, in the environment, background, and atmosphere rollout, you can control how the image-based lighting is being used. So the physically based right here setting provides automatic and optimized image-based lighting. And in this case, the software automatically uses a hidden sky dome to provide the IBL. Then we also have the motion blur rollout, where you can control the motion blur options. However, it's better to leave the settings as is, and we should respect the settings that are defined in the physical camera. So let's go ahead and demonstrate it in the software. So what I have done for most of them, I have put the pictures. I have rendered them beforehand and put the pictures. I will render a couple of them in real time, because it will take, otherwise it takes a lot of time to render those scenes by increasing the different camera, AA, and diffuse and all that stuff. So let's go ahead and have a software demonstration. So this one, the first one, I have rendered the scene, and without making any changes or modifications to the render setup, Arnold render setup here. So what you can see is that it is completely, it is overall dark, and although there is sunlight that is coming in through the windows, there is still a lot of noise there. So we have to tweak the and modify a little bit of the render parameters to just make a better renderer, rendered image. Or so we'll open the render setup dialog box right here, and you can see that we have the Arnold renderer, which has been already set, and then we'll open the Arnold renderer tab. So these are the parameters that we will be tweaking today to make the render look better. So to initially begin with, what I'm going to do is I'm going to just set this camera AA to 4 and keep an eye on those values here. So it is a multiplier for diffuse, specular, and transmission. So you will see that it will immediately change the values of those, all three of them together. So as soon as I hit that, it makes it 64. So this is the ray depth and the number of rays that come in through the camera, and then they calculate those number of rays and give you the information back. Now, if I render the scene, re-render it, you will see it will be much better than what it is right now. So it might take me a couple of seconds here and there, and couple of minutes, I would say, to render the scene. So yeah, it's doing it right now. So you can see how the bucket render works, and each portion is being rendered and then calculated and then rendered back. So it takes a bit of a couple of minutes here it will take, and for the rest of them I won't re-render the, I have also made this image smaller, but still it takes a couple of minutes and we don't have that much of time. So now this is done for the when we change the AA to 4, and this is here. You can see it's a much better render. But again, just notice there is a lot of noise going on, and there is also you cannot see outside anything outside. So what we can do is to improve that is we can just change the diffuse samples, increase the diffuse samples individually. We don't need to go and change the camera multiplier and make it 4 and 4. And with this, and I'll go back into my PowerPoint presentation, and I will probably show you. So this is with this was the first render without the modifications. This is with the camera AA4, and now that I changed the diffuse samples to 4 and ray depth to 4, you can see how much better it is looking. So it has increased. It increases the render time, but at the same time, the quality has improved. Although there is still a lot to do. So next, what we will be doing is to see outside, we will be just changing this transmission ray depth to 4. And once you do that, and you re-render the scene, once you re-render, I'll go into my presentation and show you how that will look. So the next one will be with the transmission change to 4, and you will see you are now able to see outside of the windows, and that's what the transmission does. So next one, to improve it significantly, what I have done is I will be changing this camera AA completely to 10. And this will modify, and this will recalculate all those, the minimum, maximum values of diffuse, specular, and transmission. But at the same time, it's going to increase the render time by significantly. So I have already done a rendering and put out an image in my PowerPoint slide. So it's the next one, and this is where you are now after applying camera AA to 10. So as you can see, the setting up of all the different components of setting up the different components of the Arnold Renderer, how easy it is to just modify them here and there and then get a beautiful render out of it. We can still tweak it a little bit. We can still add a little bit more ray depths and those things. We can also use the clamp sample values to get rid of those overly bright pixels in the middle. We can do that and produce a highly photorealistic render of the rendered image. So with this, I conclude, and to summarize, so in today's webcast session, we were able to do the following, which is an overview of, I gave you an overview of the Arnold Renderer, different materials that are provided in the Arnold Material library. I was also able to create metal material by modifying the Arnold standard surface shader. We also created glass material by modifying the Arnold standard surface shader again, and create Arnold Lights to illuminate a scene. We also tweaked the intensity of the Arnold Lights and then to illuminate the scene. We also worked with the controls in the Arnold Render Setup dialog box, and then modified the sampling and ray depth values to produce a high quality render. So that's about it. And now the next one, this slide is about the Autodesk 3ds Max 2018 Fundamentals Training Guide, and this is available for you. I brought all that information from that training guide. So like other training guides, this training guide has an Autodesk authorized publisher branding. This training guide has a typical ASCENT layout where each chapter has the learning objectives to help you understand what you will be learning. At the end of each chapter, the chapter review questions are provided to quickly review and refresh what was learned in the preceding chapter. An appendix is also provided at the end of the training guide, and that helps you to prepare for the 3ds Max Certified exam. There is the instructor tools that's available, which can be used along with the training guide. It provides you with the answers for the chapter review questions and also gives you the suggested timing that is required to complete each chapter in the training guide. So these are the list of available titles in the visualization lineup that are offered by ASCENT. We have the 3ds Max 2018 Fundamentals, from which I used the information for today's presentation. Also in the visualization lineup, here we have the Navisworks 2018 Essentials, and all these training guides are released and available as well.